All right, so we've touched on the subject of descriptive statistics a few times now, but I'll add a final definition here. The purpose of descriptive statistics is to summarize the characteristics of a variable. In other words, descriptive statistics reduce a large, often incomprehensible array of numbers into just a handful of figures that describe it accurately. It's essentially data analysis as you know and love it, turning data into insight. Now, let's look at these student grades from the project dataset, for example. We could spend a good couple minutes going through all 95, and ultimately, we're probably not going to have learned anything from it. But if I were to show you something like this, which has just 4 descriptive statistics, well then in a few seconds you'll have a pretty good idea about the grade for this class. We use the mean to show the average score, the min and max to show the range of grades from the class, and a histogram to show the most and least common grades, or the grade distribution, if you will. Now, we'll dive deeper into all of these as we get further along into the section, but the key takeaway here is that descriptive statistics let you use a few numbers to provide a quick, clear idea of what a lot of numbers looks like. And that's critical in getting those decision-making gears turning. Okay, so if the purpose of descriptive statistics is to summarize the characteristics of a variable, then we need to discuss the different types of variables. Now you might run into different breakdowns in other stats classes or textbooks, but ultimately there are 2 main types of variables in a dataset. You've got numerical variables and you've got categorical variables. Now numerical variables represent numbers that are meant to be aggregated. So these are things that you add up or you calculate averages for. And categorical variables represent groups or categories that can be used to cut or filter numerical variables. And we'll see an example of that in a few seconds. For now, let's take a look at the variables that we have in our project, which are really the columns in our dataset. Now, I want you to pause the video and quickly think about which of these variables are numeric and which are categorical. I'll wait. All right, let's break this down. As you might have guessed, the numerical variables are all of these in the left with the numbers, right? And the categorical variables are all the others. Now we do have this curious exception in the student ID because even though these are technically numbers, it is still a categorical variable because these numbers aren't meant to be aggregated. The sum or the average of the student IDs doesn't really mean anything. They're ultimately just numerical labels that are used to identify or filter each student. And another way to think about it is in terms of a possible question that you could have about the data. Something like, what's the mean annual salary by work experience? Well, that clearly shows that we're aggregating the numerical variable, which is the annual salary, and we're filtering it by work experience, which is categorical. So again, that's your quick intro into the types of variables and how we're going to be using each type going forward. Okay, so now that we know the types of variables, let's talk about the 3 main types of descriptive statistics that we can apply to them. And these are distribution, central tendency, and variability. Now, what the distribution does is represent the frequency of each possible value in a variable. So in other words, how many times does each of these values occur? Now, some examples of these are frequency tables and their database equivalent, histograms, which you've already seen an example of. And if we take a closer look at it, then we can see exactly how many graduates fall into each grade bucket and how that frequency varies by bucket. So this is going to give us a pretty good idea of the overall shape of the data. Now, the measures of central tendency, on the other hand, represent the middle or center of the values. And some clear examples here are the mean, median, and mode, but we'll also discuss the concept of skew later in the section. And the example that we've seen already is the class average, which is a mean, and ultimately tells us that most of the grades fall around that number. And if we look at the histogram again, then we can actually confirm that most values are between 80 and 85, 75 and 80, and 85 and 90. And finally, the measures of variability represent the dispersion or the spread of the values around their center. Now, these are often the most overlooked, but are ultimately the most important when talking about statistics. It's where that randomness and the uncertainty kicks in. Now, some examples of these are the min, max, and range, the quartiles and the interquartile range, box and whisker plots, which are a type of data visualization, and finally the infamous variance and standard deviation. Now, some of these words aren't as universally well known as the mean, so don't worry if you don't understand them yet. But the idea here is that if the measures of central tendency reduce a bunch of numbers into a single point, like 80.17, then these measures of variability give you some context as to how spread out the numbers actually are around that number. For example, the highest and lowest grades that we showed earlier. And as a quick disclaimer, most measures of central tendency and variability can only be applied to numerical variables, so that's where we're going to be focusing them on.